Hi, this is Zhao Peng. I'm a doctoral student at Carolina Health Informatics program at UC Chapel Hill. I'm interested in learning about how people exchange information over dialogue, and therefore I have a lot of opportunities to interact with the textual data. In this section, I will briefly talk about three important tasks you'll be dealing with in text information extraction. They are part of speech tagging or post-tagging, name identity recognition or NER, and relation extraction. Before we dive into the details, what do we mean when we talk about the text information extraction? As we got a chunk of text, like the text on the Wikipedia page of the NIH, we got unstructured data, which are not organized in a predefined manner. The computer cannot recognize and interpret them. How can we extract interesting facts out of them? It's like many dots scattered randomly in this plane. When we use text mining techniques to digitalize the text, we're making the text more processable for the computer. We look at the text objects and how they are correlated with each other. So far, the unstructured data becomes more structured and makes more sense. As the information is gathered and relations become clearer, we can figure out some particular types of information that describes facts about NIH, like the number of employees, annual budget, sub-agencies. Over the course of this procedure, we're trying to extract the information objects that we're interested in and the relationships between those objects. By answering what they are and how they are related, we gain knowledge and insights from the text. First, post-tagging. When we learn language in a school, we were taught that a word can have categories in a sentence, like the noun, verb, article, adjective, etc. For example, in this sentence, we have dog and sausage as nouns, spicy as an adjective to modify the sausage, like as a verb to describe the relation between the dog and sausage, and the my to specify the dog and also to specify the situation of the like. What we are doing here is describing the lexical features and function of each word with a label based on its definition and context. These tags are not trivial, because in many cases, a word can have more than one category in a sentence. With the post-tagging, we can distinguish those different categories. For example, here we have likes in three sentences. The first like is a verb, the second is a preposition with the meaning of the having the same characteristics as. The third like is a conjunction which introduces a clause, working similarly to the phrase as if. With this tags, we can determine the unique lexical category of a word in the context of the sentence. Now, what types of tags can we use to label the word? There are more than 20 types of post-tag sets developed in the computational linguistic community. Some of them have fine granularities, while some are coarse. One of the most commonly used post-tag sets is the pain tree bank, which was developed in the University of Pennsylvania in 1989. This tag set contains 36 post tags and 12 other tags like the punctuation and currency symbols. Another very popular one is the universal tag set developed in 2012. This tag set is less fine-grained, but more flexible and simpler to use if detailed distinctions are not required. For example, the adverb in pain tree bank are classified into three different types, whereas the universal set only has one. You can also see the verb in the pain tree bank has 6 different types in terms of the tense and singular or non-singular, but the universal set only has one. These tag sets try to identify the basic lexical categories of the words in a sentence at different level of detail. The post-tagging can help us do many things. It can help us with syntactic chunking, that is, identifying the proper combination of words, such as the phrases. A phrase generally provides us with more detailed information than a single word. For example, in this sentence, we want to extract the noun phrases. Normally, a noun phrase consists of a determiner, which means article, the a, maybe an adjective, and ends with one or more than one nouns. We assign post-tags to each word and extract the noun phrases based on that pattern. Another use case can be sentiment analysis. Sentiment means the positive and negative emotion of a sentence. The emotion is largely determined by the adjectives and adverbs in a sentence. Look at two Yelp reviews on the right. One is positive with the words like good, reasonable, and attentive, while the other is negative with words like worst and misleading or fraudulent. Okay, now we have a basic sense of what post-tagging is and how it helps us in text mining. In addition to syntactic chunking and sentiment analysis, what else use cases you can think about of the post-tagging? And it's time to play with the code below. Tag the words and extract noun phrases. In this part, we will talk about the name entity recognition, or NER. NER is a task where we find out the key information objects and categorize them into predefined classification, such as person, organization, and location names, and numeric expressions, including time, date, money, and percent. It helps us to answer a question: who did what, at when, in where? Here is an example. The NIH was founded in 1887 and is now a part of the United States Department of Health and Human Services. The NIH is located in Maryland, US, and has nearly 1,000 scientists and support staff. The NIH obtained $39 billion from Congress in 2019. This text contains several facts about the NIH, and we can extract information like organization, date, money, cardinal number, and geopolitical entities such as countries, cities, and states. The NER can be also used in the biomedical text. For example, in this patient history report, we can extract information like the patient's symptom or test or treatment he or she has taken in the past. There are many biomedical entity recognition tools available for us. You can check them up in the appendix of these slides. Okay, in this part we talk briefly about the name entity recognition and its practical uses. Considering the topic you are interested in, think about what types of entities are important to extract. In Jupyter Notebook, you will extract the name entities, use spacing. In this part, we will talk about extracting interesting relation of the information objects in text. But before that, we would like to learn about what is the syntactic dependency structure of a sentence, which is very necessary for us to figure out essential relations. We're going to use the same example. My dog also likes spicy sausage. The verb likes has one subject and one object. The sausage is modified by spicy, giving us a noun phrase. Also is an adverb modifier to likes. The my here is the possessive term to specify which dog we're talking about. The verb likes determines the action of the entire sentence, and the other parts seem to directly or indirectly depend on this verb. In this case, we call the verb the head of the sentence, and call other words as dependents. In this sentence, for example, likes is the head of dog and sausage. A dependent also can be a head of the other dependents. The sausage is the head of spicy in the noun phrase, and this binary hierarchical and asymmetric relation between terms represent what we call syntactic dependency structure. And there are many interesting attributes of this relation. For example, the head determines the syntactic category of the component it involves in, such as in likes spicy sausages is a verb phrase because the likes is the head and it is a verb. We will not dig into the detail in this course. If you are interested in more about this, you can Google dependency grammar or dependency parsing for more detail. Why do we analyze the sentence structure in this way? Because that will help us figure out which components bear the most important semantic meaning of the sentence, and which components just provide complementary information. Now, we have talked about a simple syntactic dependency structure. Let's think about the following examples, which are more complex. Check the text 3 in Jupyter Notebook and think about which might be the head and which might be the dependents. The dependency analysis helps us parse the syntactic structure of a sentence and figure out its semantic meaning. In this sentence, dog, like sausages, serves the major part of the meaning. Linguistically, we can represent this relation with a predicate-argument structure. A predicate generally refers to the verb that connects to the subject of a sentence. It functions as a glue to hold close together and construct the backbone of the sentence with the subject. The arguments on the other side helps complete the meaning of a predicate and closely connect to it, such as the subject argument and object argument. In this example, the legs is the predicate, the dog and sausages are subject and object argument, respectively. Along with the predicate, the arguments deliver a complete thought of the sentence, which is dog like sausages. How could we figure out such subject-predicate-object relation? As long as we find out the height of the sentence, which is a verb, or we can call it a root, we can visit the other important arguments by traversing such syntactic dependency structure. In this example, we traverse from legs to dog, getting subject, from legs to sausages, getting object. This subject-predicate-object relation extraction can be very useful in text mining and knowledge extraction in biomedical domain. For example, physicians and scientists always need to keep up with the most recent clinical evidence to better support the decision-making with patient care, such as if a new drug is effective or has interactions with other drugs or result in side effects. The relation extraction can facilitate this process. For example, in this research paper, we used hemofiltration to treat a patient with a digoxin overdose that was complicated by refractory hypokalemia. Don't be overwhelmed by these crazy terms. It is just saying that a technique is able to treat a patient with a symptom that was complicated by another symptom. We can extract some key relations from this text. This will save healthcare professionals a lot of efforts and time in finding evidence and avoid human errors. In this part, we talked about syntactic dependency structure and ease to use in biomedical domain. In task 4, you will extract such relation using the syntactic dependency you identified in last task. This is optional. You can move on to the Jupyter Notebook for more detail. Also, if you'd like to explore more about biomedical relation extraction, you can try this tool, which is developed by NIH. You can also play with other tools provided in the appendix of these slides. In this section, we first talked about the PosTagging, which assigns a lexical category to each word to distinguish them among the sentence. We also talked about the NER, which labels entities with a predefined meaning. We in the last talk about the syntactic dependency structure and how to use it to extract subject-object relation. These 3 tasks are essential components of text mining and natural language processing. They help us turn unstructured data to a structured format and identify important information objects and their relations.